air track, a powerful magnet was positioned between the two light gates so that the aluminum plate will pass between the poles of the magnet. And that's exactly what's being displayed here. As it's passing here, it will pass at a given velocity. Then once it's going to pass, this aluminum plate is going to cut through the magnetic fields. The vehicle was given a push. The aluminum plates took 0.19 to pass through the gate 1, this gate 1 here. Then you are supposed to show that the momentum of the vehicle was about 0.3 Newton seconds. And then remember, speed is equal to length of the speed is going to be the length of this particular aluminum plate divided by the time it will take to run across there. So this is going to be 0.789 meters per second. But momentum is given by the formula. Momentum is equal to mass times velocity, which will mean that if you do the calculations at that point, you're going to have your value as 0.3156 Newton seconds, which is approximately 0.3 Newton seconds as it was given at that point. Then also we are told that the vehicle is then moved between the poles before passing through the gate 2. The magnet caused the kinetic energy of the vehicle to reduce by 10%. So meaning we can be able to get the kinetic energy when it passes there. But we shall say initial kinetic energy is equal to the new kinetic energy. The final kinetic energy will be equal to the original kinetic energy times 0.9. Why 0.9? Because we are told we reduce by 10%. So the kinetic energy that will be remaining will be 90%. So 90% as a decimal will be 0.9. So that's why you can see my new kinetic energy will be original kinetic energy times this value. But the mass, remember, will be the same for both cases. So mass will cancel out, and if you work out the final speed, is going to be 0.749 meters per second. That's the final velocity it will be passing through the second case. Explain why the current was produced in the aluminum coil. Now this is the concept of electromagnetic induction. When the coil could pass through the poles of the magnet, that is going to cause what we